Generating ketone bodies is done in general by free fatty acids entering the liver from circulation. And the liver can convert free fatty acids into ketone bodies, which are short chain fats that are water soluble. They're water soluble molecules that have a distinct benefit in getting to the brain, which free fatty acids can't because they're too big to get through the blood-brain barrier. And so this was a tremendous survival tool back when we went considerable periods of time without eating or with not much to eat as part of our ancestry. So ketosis, normally, as I talk about in the book, should actually happen every night after about 8 hours of not eating. Most people with metabolic flexibility, most people don't have metabolic flexibility.
88% plus, according to a study that came out a few years ago. Dr. Steven Gundry, thanks for joining me on the Keto Camp podcast today.
Thanks, Ben. Great to be here.
You are rattling some keto cages with your brand new book titled Unlocking the Keto Code, the revolutionary new science of keto that offers more benefits without deprivation. The book is out. By the time this podcast is out, the book is out right now. So we'll talk about where you could get that. And I read the book. Your team sent me an advanced copy, a PDF copy, and I just loved it. Speaking my language, we have a lot in common that we share, and it was really cool to see that. And there's some things that I actually want to get clear on myself. So let's dive right in. I want to first ask you this. What is your definition of the term ketosis?
Well, generating ketone bodies is done in general by free fatty acids entering the liver from circulation. And the liver can convert free fatty acids into ketone bodies, which are short chain fats that are water soluble. And we can get into why we make them, but you and I think know why we make them. But they're water soluble molecules that have a distinct benefit in getting to the brain, which free fatty acids can't because they're too big to get through the blood-brain barrier. And so this was a tremendous survival tool back when we went considerable periods of time without eating or with not much to eat as part of our ancestry. So ketosis, normally, as I talk about in the book, should actually happen every night after about 8 hours of not eating. Most people with metabolic flexibility, and do we have to define that term, or does everybody know it?
Everybody knows it, yeah.
Okay, good. Most people don't have metabolic flexibility.
88% plus, according to a study that came out a few years ago.
And I use that study in the book. And in fact, 50% of normal people are not metabolically flexible, which is actually maybe more shocking than 88% of overweight people, and 99.5% of obese people don't have metabolic flexibility. But get back to the point. Normally, if you have metabolic flexibility, about 8 hours after you stop eating, you will begin to convert free fatty acids into ketones in your liver. And by 12 hours after eating, you've ramped up ketone production pretty good. And I think that's important for everybody to know, that producing ketones is a normal process that should happen every 24 hours in a circadian rhythm fashion. And hopefully we'll get into why you and I think that's so important. So,
yeah, and your problem, I'm going to use the word problem, with a lot of people in the keto space, and you do a good job at being respectfully disagreeing with individuals, but you have quotes from people that you've come across in the keto space. You know, keto does X, Y, Z, it does this, the fourth macronutrient, et cetera, et cetera, et cetera. You know, I'm actually guilty of a few of those, and I've changed.
So was I.
Yeah, I know. Yeah. So we were just talking about that. But I want to understand here, and you talk about it really well in the book, the mitochondrial uncoupling and why that's the goal, right? So could you explain what exactly that means to the average person? They probably have no idea what that is.
Right. And maybe even before we get there, let's make one thing clear. I've had a ketogenic version of my diets in every one of my books, and I strongly believe in the benefits of ketones. And I was mistaken as to why I strongly believed in the benefits. I certainly saw the benefits in my ketogenic diet. But when you actually look at the research that George Cahill did and his student, Dr. Owens, and Veach at the NIH, you actually see a different picture in human subjects of what all of us thought ketones were doing. Dr. Owens' work in 2004 in humans showed that even at full ketosis, the body only uses 30% of the fuel as ketones. The rest come from free fatty acids or glucose. And the brain, which ought to use ketones exclusively, only 60 to 70% of the brain's needs are met by full ketosis. And it still wants 30 to 40% of its fuel as glucose. So, and these are human studies. These aren't rats or anything else. So we've got to lose the narrative that this is somehow, the perfect fuel. It's clearly not, but it's a really important signaling molecule. So when I realized that, holy cow, have I and others got this wrong? What the heck was the benefit that all of us were seeing in ketones? Where was the weight loss coming? Where were some of the other remarkable health benefits coming from? And that's when, in a way, I stumbled on a paper written by Martin Brand in 2000, which I recommend anybody listening or watching this show go read. It's short, it's easy to read, and it is paradoxically, I hate to use that word, probably the most mind-bending concept there is. And it's called Uncoupling to Survive. That's the name of the paper. And he said, and anything goes along and proves it, that in extremis, when you're starving to death, when there is no food, that mitochondria have to save themselves at all costs, because if mitochondria die,
we're done.
We're done. That's it. Game over. So mitochondria making energy, making ATP is really hard work. It is very damaging to mitochondria. Most of us know about free radicals, reactive oxygen species, constantly damaging to mitochondria. And mitochondria have to have ways of protecting themselves. And one of the ways they protect themselves from too much pressure within the inner membrane of the mitochondria is to release that pressure, if you will, by pop-off valves, very much like a pop-off valve in a pressure cooker. If pressure gets too high in a pressure cooker, you release steam and pressure, and that keeps the pressure cooker from blowing up, which my mother did as a child. Really fun. So they propose that mitochondria ought to have these pressure release valves. And in fact, they do. There are actually 5 pressure release valves, and they're controlled by what are called uncoupling proteins. Now, where the word uncoupling came from, I didn't make it up. I spent about 6 months trying to figure out, I got to get a better word, because most people think of uncoupling as my friend Gwyneth Paltrow getting divorced.
Right.
So we couple oxygen and protons in mitochondria, and that coupling of
there's like a sound. There was a sound that I was hearing.
Oh, that's probably this.
The mic, yeah.
Yeah, sorry. We couple oxygen and protons to make ATP, and byproducts are water and carbon dioxide. So we couple those molecules, and getting those molecules to couple is actually really hard work. On the other hand, if we uncouple the burning of oxygen from making ATP, we uncouple oxygen burning to combining it with a proton, That's how we release these pressure release valves. So the word uncoupling came from, okay, a bunch of the protons, a bunch of the calories that we would use to generate ATP, we're going to throw out emergency exits. And we're just going to not use them at all. We'll keep burning oxygen, but they're not going to make ATP. So Brand said, in extremis, the mitochondria ought to really aggressively uncouple themselves to protect themselves from damage because they've got to survive. And people went, what the heck? That doesn't make any sense. If you don't have much food, why would you waste food? Well, Brand had an answer. He says, well, if you don't believe me, let's look at super, super old people, 105 years old, who are thriving. And let's measure their uncoupling proteins. And lo and behold, he found that people who are thriving at 105 have the most uncoupled mitochondria of anybody. And so it begins to make sense. Now, ketones, it turns out, uncouple mitochondria, and they do it very well. But in this process of uncoupling mitochondria, they actually do two other things. Number one, they tell mitochondria to make more of themselves, mitogenesis. And number three, they tell mitochondria to aggressively repair themselves, to spend all of their efforts to protecting themselves, to cleaning up the mess that normally occurs, because they've got to save themselves at all costs. And what's really exciting about all this, so for instance, let's suppose we have a dog sled and we have one dog. Yeah, the dog can pull the dog sled, but it's not going to go very far. On the other hand, if you have 6 dogs on the dog sled, each dog has to do a sixth of the work that that one dog did, and they'll go a whole lot farther. The only side effect of that is you got to feed 6 dogs instead of one dog. And so another way of looking at this is we're going to have each mitochondria work a whole lot less than it normally would, but we're going to have a whole lot more mitochondria. And so we're actually going to burn more calories, use more calories to protect each individual mitochondria or dog. And that's actually where the weight loss comes from. And so it's a whole new way of looking at what the benefit of ketones really are.
So to clear some things up here, when we look at a cell that's running off of glucose, only burning glucose, sugar, somebody who's metabolically inflexible, how much ATP on average is that cell producing versus a metabolically healthy, flexible cell that's using now fat and ketones?
Well, so in general, you make 32 molecules of ATP from a molecule of glucose. Incredibly efficient. But one of the things that when you look back at the history of trying to figure out the electron transport chain, is that biochemists were the original people who were fascinated with this. In fact, Otto Warburg was deeply involved with this. And whenever biochemists would isolate individual mitochondria and run what their equations would predict, they actually got quite varying results with the molecules of ATP that they put into the system. Sometimes they get 32, sometimes they get 30, sometimes 31, sometimes 34. And everybody was arguing, well, your equation is wrong. And it wasn't until Peter Mitchell proposed the theory of the electron transport chain. And it was actually a theory. He never actually proved it. Turns out he was right. He says, look, the equation is wrong because these things don't behave like your chemistry books. They have these pop-off doors that get rid of some of the calories that could make up into ATP. So, and we call it beta oxidation, but you're right. So if we're measuring basal metabolic rate, ketones or burning ketones or burning free fatty acids actually have a higher metabolic rate but in terms of ATP production, it actually may be less or more depending on how much uncoupling is occurring.
So, okay, this is interesting. So when we're looking at just basic biochemistry, the textbooks, it's showing that there's 4 times more ATP created from fat and ketones versus glucose. But what you're saying is that's not necessarily the case. It depends on what's happening with the uncoupling. Is that what you're saying?
Number one. And number two, we're forgetting that ketones will actually stimulate mitogenesis. So you'll have a lot more mitochondria in a cell generating far more ATP, but not each individual mitochondria is doing that. The collective mitochondria are doing that. Does that make sense?
Yeah, got it.
It's like we've got 6 dogs on the sled now instead of 1.
Mm-hmm. So I want to get something straight for my work, right? Because what I used to say, and I want you to correct me if this is something I shouldn't say anymore, when we're looking at sugar burning versus fat burning, I give a simple analogy and you tell me if this is the wrong analogy and you give me a better one if there's a better one. A cell that's stuck burning sugar and glucose is inflammatory, similar to a truck with all this smoke being blasted out of the exhaust pipe. A cell burning ketones, cleaner energy, similar to a Tesla. Now, you're shaking your head no, so I'm looking at you and you're going to correct me on the analogy and explain why I'm wrong with that.
Well, and that's why I put one of those quotes from the books, and they're all true quotes. The innocent are protected because I didn't put their names, but I've got the books on my shelf. Anybody want to see them?
Look, so, I'm open. I'm open like you. So always changing my ways, and I want to get it right. Yeah.
Nothing wrong with glucose. Glucose is not a dirty fuel any more than ketones are a clean burning fuel. They really aren't. Ketones are, we got to remember that ketones were generated for one reason and one reason only, and that's because they are the only fuel that can get, besides glucose, that can get past the blood-brain barrier quickly. And they were a survival mechanism for the brain to, in times that are tough, or when you're not eating anything during sleep. And we have to remember that. So they're not some super fuel. And again, Dr. Owens proved this. Dr. Cahill proved this. Even if you look at Vogel's and Finney's work, they show that athletes on a ketogenic diet have decreased performance for 2 to 4 weeks before they become keto adapted.
Why do you put that in quotations?
Well, it turns out if you then look at Owens and Cahill's work, at 3 days in a ketogenic state, after 3 days, muscles prefer ketones as their primary fuel. Remember that, 3 days. But beyond 3 days, muscles prefer free fatty acids as their primary fuel. So if that's true and ketones are some super fuel, then Finney and Vogel should see the opposite, that the athletes 3 days into a ketogenic diet ought to have the best performance. And in fact, they have the worst performance, even though the muscles are burning ketones as their primary fuel. And when I started looking at that, I go, holy cow, how wrong could we have been about this? The literature is there in human beings. We just weren't aware of why ketones were so useful and why it took 3 to 4 weeks to become keto adapted was because you were spending that time building more mitochondria. You were spending that time putting more dogs attached to the sled.
So what is the half-life of the mitochondria?
That's actually a great question. Mitochondria can live forever if you don't damage them. They have the ability to, as long as you don't damage mitochondria, they'll stay as long as the cell stays. But as you and I know, the problem is our current diet is really good at destroying mitochondria. And as I talked about in the energy paradox, my previous book, once a mitochondria is damaged, we forget that mitochondria are actually engulfed bacteria. and they still carry a bacterial identity. They have their own DNA. They can divide anytime they want without the cell division. But when a mitochondria is damaged and destroyed, it actually creates apoptosis, which is explosion of the cell rather than autophagy, which is self-eating the cell. So now you're spewing pieces of mitochondria, which the immune system views as a bacterial cell wall. And that's where that inflammatory process comes from dead mitochondria. So you want to keep your mitochondria happy. And the book explains how we got to keep cleaning up the Mito Club.
Yeah. And
Right?
I want you to get into the Mito Club. Brilliant analogy. And we'll talk about some of your codes to unlocking. I'm not going to give it all away, but we'll talk about some of the codes to uncouple the mitochondria. But I still want to stay on this topic real quick
Sure.
before we move on to the Mito Club. So if we have healthy mitochondria, they'll stick around forever until they become unhealthy, until apoptosis occurs. But if autophagy is occurring, that could repair the mitochondria and it could still stick around, right?
Correct.
But most people are experiencing apoptosis. They're experiencing cell death. They're experiencing inflammatory markers. So what would you estimate for the average American is the half-life for mitochondria? Would you say 3 to 4 weeks?
Probably in the average American, much less than that. And that's unfortunately one of our big problems. And we can argue where inflammation comes from. I happen to believe Hippocrates was right that all disease begins in the gut.
Yeah.
And I think if you got a leaky gut, that's where inflammation comes from. And I've spent my last 20 years trying to prove that.
Yeah.
And Hippocrates knew it 2,500 years ago. So who am I to say?
You've done a good job carrying his work. And the word on carnivore, you're like the original carnivore guy, which I love carnivore as a tool. Okay, so I want to get clear on 3 different processes here before we move on to the Mito Club. Let me just go to my notes here. So what's the difference between, I want to hear your explanation of the difference between being in ketosis, being fat adapted, and being keto adapted. Could you explain the 3 different processes here?
Yeah, so good news is, bad news is almost most people cannot get into ketosis using a high-fat diet initially because they have no metabolic flexibility. And here's the sad thing. Insulin, most of all of us know about insulin. Insulin rises when we eat sugars and proteins to usher sugar and proteins into primarily muscle cells. And when insulin rises, it literally is a salesperson that sells what we ate to the muscle cells. Now, insulin has no interest in fat as a food. Insulin would not rise when you and I eat a stick of butter.
Or your favorite olive oil.
Or my favorite olive oil. Insulin would not do a thing. The problem is most of us are insulin resistant and our cells no longer listen to insulin, so insulin keeps rising and rising. Now, when we've eaten enough and all of our cells are full, insulin then can no longer sell glucose and protein to muscles, but it's got a lot of extra calories, so it converts these into fat. And it turns on an enzyme called lipoprotein lipase, which converts these into fat, opens up the fat cells. Now, if you're trying to store fat, it would be a dumb idea to try and get fat out of fat stores because you're trying to put it in. So when insulin is up, when it's released, it blocks fat release from fat cells. It blocks another enzyme called hormone-sensitive lipase. I wonder what hormone-sensitive lipase is sensitive to. Insulin. So here's the gut check, if you will. Most of us have elevated insulin. So when we stop eating carbs and really diminish our proteins, one would hope that hormone-sensitive lipase would fall and release fat from fat cells. Insulin prevents that. And you can actually show in humans that it can take 3 to 4 weeks minimum to actually liberate fat from fat cells on a ketogenic diet because insulin levels stay so high for so long.
So is
And
that why, sorry to cut you off, but is that why if people don't follow your tips and you teach them how to prevent this problem in the book, but is that why so many people who just do high fat, low carb, it takes 3 to 4 weeks for them to enter ketosis? Is that what's happening?
that's exactly right.
Okay.
That's where, the Atkins blues come from, the keto flu comes from. And there's some really cool human studies that I didn't include in the book. We cut lots of stuff because I get boring. It's so nerdy. But there's some really cool studies looking at low carb ketogenic diet in humans and looking at energy expenditure, basal metabolic rate, versus a standard carbohydrate diet. And what happens in these studies when they bother to measure it is it takes 3 to 4 weeks minimum to begin to see an increase in basal metabolic rate in the ketogenic diet folks. And you never see that in the carbohydrate groups. And so, and this shows in ketogenic studies, and the basal metabolic rate doesn't go up until you start producing ketones. And the reason the basal metabolic rate goes up is because you're uncoupling mitochondria. And so you're actually burning oxygen without producing ATP. So your BMR goes up.
Interesting.
Cool.
Yeah, that is super cool. And we're going to share some ways for you to not have to wait 3 to 4 weeks. You talk about that in your book. And you also have a story of your patient, Miranda, who went through the same problem, what we're talking about here. Before we get to that, and the Mito Club we'll transition to in a second. Okay, I want to really understand. So if somebody's metabolically inflexible, you said it doesn't really matter in terms of both can be efficient. Glucose and ketones, one is not cleaner than the other, according to you. But what about the studies that show ketones lower free radicals, reactive oxygen species? Like, I don't see some studies showing that in the case of glucose, but I see some studies showing that with ketones. Wouldn't that help make it a cleaner fuel, or is there something else going on that I'm missing here?
Yeah, you're missing the fact that ketones work by uncoupling mitochondria.
Okay, so it's going right back to that.
And when mitochondria are uncoupling, they don't produce as many free radicals and reactive oxygen species because they're blowing off the pressure.
So
boom.
Does glucose uncouple proteins, mitochondria? Excuse me.
No, not at all.
So with that, if ketones are uncoupling mitochondria, then it would be a cleaner source?
No, it'll be a less damaging source. There's a difference.
There's a difference.
Yeah, they protect mitochondria from damage, and that's the whole idea of uncoupling mitochondria, and that's what Martin Brand proved. That the benefit was not that they're a clean burning fuel, but they prevent the damage that would normally occur from burning glucose. Does that help?
I got it. So what would be a good analogy for that? I mean, you're the king of analogies. So how would you explain that for, is something coming to mind, an analogy you would use for that process?
Well, I use the example of a pressure cooker, but one of the
what I'm saying is glucose versus ketones.
Yeah, so ketones were generated, quite frankly, for two purposes. You and I, and most of your listeners, know that they were generated to be an alternative fuel source for the brain. Because when glucose ran out, free fatty acids cannot get into the brain. They technically can, but they're so big and slow that the brain, which is a fuel hog, can't get enough of them. But these short chain water-soluble fats can get into the brain. But number two, if things are really bad, if you're literally starving to death, then ketones start telling the mitochondria, whoa, things are really bad here. We can't just rely on this as a fuel. We've got to protect ourselves, from damage, and we got to make more of ourselves. And that's where you really start saying, holy cow, I got it wrong. Most of us got it wrong. This has been known about. Believe it or not, uncoupling proteins have been known since 1978. That's when they were first described. But we just haven't. Some people describe me as flying at 30,000 feet, and I can kind of see things. I don't know, but that's been my life's work. I disrupted heart surgery, and I disrupted healthy eating with the plant paradox. So
Yes.
don't get me wrong. Ketones are great, folks. Everybody listening, I have nothing against ketones. I love ketones, but I think people have called me the father of the carnivore diet, and I'm not sure I want that title, but well, I guess I'll take it. So yeah, don't get me wrong. Ketones are really good, but why they're really good is for a reason that I think we should all embrace and understand that there are other ways to get the same effect without doing what we call a ketogenic diet.
Understood. And
can I add one more thing, which is a good segue?
Of course.
Okay, so hopefully everybody knows the ketogenic diet came about to treat childhood epilepsy, and it started in 1930 at the Mayo Clinic. And this was an 80% fat diet, 10% carbohydrate, 10% protein, classic ketogenic diet. And the kids actually did remarkably well. But as any parent knows, kids love carbohydrates, and it's a very hard diet to stick with. As so many keto dieters know, it's really hard to lose that carb hunger. In fact, it really never goes away, as I show in the book from research at the University of Sydney. So the ketogenic diet for kids fell off when pharmaceuticals came along, like Dilantin and Phenobarb. Yeah. But it actually had a very interesting resurgence in the 80s and 90s when it was found that MCT oil, which is medium chain triglycerides, if you put kids on an MCT oil-based diet with only about 50% of their calories coming from fat, they would get the same benefit as the full-blown ketogenic diet, but they could have a whole lot more carbohydrates and a whole lot more protein. And they became incredibly compliant. In fact, I recently have a 17-year-old high schooler with horrible seizure disorder on 4 meds. And he was so drugged up, he actually really couldn't go to high school. I put him on my program with MCT oil and our other tricks, some of which we'll talk about. Mm-hmm. The guy's now off of his drugs. He's actually playing soccer for his team. And I mean, it's just, I hate to use the word miracle, but his mother certainly describes it as a miracle. And so this is one of the things you'll notice in all my books, my ketogenic diet. First thing I say is, okay, we're going to get you on MCT oil, and we're going to get the benefit of MCTs. And so is that a good segue to where we're going next?
Yeah, I want to get into the Mito and the reason why MCTs work so well, as you know and explain, they have the ability to really bypass digestion and effectively go right into the mitochondria, and especially caprylic acid is one of the most well-researched ones when it comes to ketones. So we'll talk about some of your favorite MCT sources, and I love that I saw that list because it's actually what I've been promoting. But let's talk about the Mito Club, because for those who don't understand the electric transport chain and how the metabolism works, you gave such an amazing analogy that you came up with that you put in the book called the Mito Club. So unpack that and explain what that means.
All right. So mitochondria, the electron transport chain in mitochondria, there's, I describe it as the hippest, hottest club that every Gen Zer and millennial wants to get in.
We'll call it Live Miami. That's the most popular one here. Live Miami.
Perfect. Live Miami is a great example, and Miami is a perfect example for this. You want to go clubbing. Why do you want to go clubbing? Well, quite frankly, the purpose of clubbing is to couple, right? You want to couple with somebody. That's what you want to do. Pitbull, it's all he wants to do is couple. So the Mito Club has one entrance, and it's guarded by a doorman, and there's a velvet rope. And there's only one exit out of the Mito Club. And it turns out in the Mito Club, I mean, there's hormones, there's drinks, there's the energy is seething. It's crowded. People are trying to get to the bar. People are bumping into each other. And we're actually doing this in our mitochondria. We are actually energizing electrons and protons to a fever pitch, trying to get these guys to go through the Mito Club, and hopefully, if everything works out okay, a proton and electron are going to couple, and they're going to exit the back door of the Mito Club. And it's actually a revolving door. And this is true. This is actually a revolving door at the end of the mitochondria. And as they push through this mitochondria, they generate ATP. So there's only one way in and one way out. And it's steamy and hot. And the problem is there's, in a way, a lot more, we'll call them, for the purpose of this, we'll call them girls, which we'll call electrons, and we'll call protons boys. And yes, protons can couple with protons, and we won't go there. and electrons can couple. But electrons will also couple with oxygen. And it's a bad match. Everybody knows they shouldn't do it. But these are the reactive oxygen species and the free radicals. And they're trouble. And fights break out with all of this. And there's bouncers in the club. And it turns out we only have 2 bouncers in mitochondria, 2 antioxidants. And that's a surprise to most people. The big surprise is one of them is melatonin, the quote sleep hormone. And we'll get into melatonin maybe.
Yeah.
The other
I love talking about melatonin. Yeah, for sure.
The other is glutathione. So those are the only 2 antioxidants in mitochondria. And they're there to kind of, keep peace. But what happens is that things get so rowdy that the club is no place to be anymore. Everybody knows there's fistfights breaking up. The club is dirty. There's no time to clean up. And so a lot of people get frustrated, the protons, the guys, and they're not coupling. So they go, oh, screw this. I'm going to go to the club down the street. So they push open emergency exits in the club. And these are actually the trap doors that uncoupling proteins control. And they escape from the club and they go down the street and look for other clubs. And so that's actually the pop-off valve for all of this. The other thing I point out is that the club needs to be cleaned up every night after closing. And you need a considerable time to clean up the mess. I mean, there's beer on the floor, there's broken bottles, there's, tables are broken. Who knows what's spread on the couches? As Club 54 used to have. Club 54 used to have vinyl on all the couches up in the balconies.
Wow.
Because they could wash it off every night. Don't get me started. Before your time. So anyhow, there's a method to cleaning all this up, and there has to be a downtime. And what happens is, if, let's say, the club is open from 10 o'clock at night till 4 o'clock in the morning. Well, you got from 4 o'clock in the morning till 10 o'clock the next night to clean up. But now management says, man, the club is so successful. We ought to open at noon and we'll close at 6. Well, now instead of like 18 hours to clean up, now we only have 6 hours to clean up. And things get messy. Now, it turns into this juke joint where nobody wants to go. So all of these things have to happen to keep the club the happening place it is. And popping off these emergency exits is actually one of the keys that keeps the mitochondria and the club the place to be.
And it is the uncoupling.
It's the uncoupling. It's the opening up of these, if you will, emergency exits. And there's actually 5 emergency exits in every mitochondria. And they're all controlled by what are called uncoupling proteins. And so once you go, holy cow, what are these guys doing there? And then you start looking at the effect that opening up these emergency exits have on mitochondrial health and general health. And then you start looking at, well, okay, we know ketones do this. We know ketones would have done this every night for a few hours. How can we let's stay on the ketone subject. How can we continue to get the benefit of ketones? And that's where the work by Rafael De Capo from the NIH, I think, really starts putting pieces together. You want to go that direction, or you
Yeah.
want to go in another direction?
Yeah. Let's go to that direction. Tell me more about that.
Okay, so everybody knows that the best way to extend lifespan and health span is calorie restriction. And almost everybody knows that calorie restriction is a non-starter as a useful method. Even my friend Walter Longo knows that calorie restriction isn't going to work. Nobody will do it. It's miserable.
Yeah. Yeah. You'll feel miserable. I mean, the Biosphere 2 project showed that, right?
Yeah, yeah, and actually, his mentor was Ray Walford, who was a pathologist from UCLA, and Ray thought this was the greatest thing that ever happened to his research because these guys literally starved to death. They lost 30% of their body weight in the first 6 months. And
their organs shrunk as well, right?
everything went bad.
Yeah.
And sadly, Ray Walford, who was really the father of calorie restriction, died as what I consider a young man in his 70s. And since I'm now in my 70s, I consider that a young man.
Yeah.
So that's not a good idea. But De Capo said, I think we've got this all wrong. Calorie restricted animals are profoundly hungry, and for obvious reasons. And in experiments, we control when their food is put out. And I have a feeling that when you're really hungry and somebody puts your bowl of food in your cage, you're going to eat it really quickly. And then you have to wait till the next day for the next bowl of food. So he designed an experiment that took the rhesus monkey studies from the University of Wisconsin and the National Institutes of Aging and designed a study to see if it was really the calorie restriction or it was the time of feeding that made the difference. And what he found, I'll really summarize it quickly. If you take animals and give them a full day's calories, but put it out at 3 o'clock in the afternoon, they'll eat it actually fairly quickly, and they'll go a very long time, about 12 hours without eating, which for a rat is a very long time.
Yeah.
If you give animals kind of food throughout the 24 hours, the same amount of food, they'll kind of nibble on it all day and all night. So when he looked at metabolic flexibility, which kind of started our conversation, only the animals that were given their food at 3 o'clock in the afternoon and ate it fairly quickly had metabolic flexibility. They could change from glucose to free fatty acids. The animals that ate all day and night didn't have any metabolic flexibility. Point number one. Number two, the animals that had their time restricted eating lived 11% longer than the animals who ate the same amount of food but ate it throughout the day. For humans, that's a 10-year benefit.
Amazing.
And the really cool thing is the animals with the time restricted eating didn't develop amyloid plaques in their organs or their brain. And these animals tend to die of liver cancer, interestingly enough, and they had far less liver cancer. So that's now been proven in humans with the Italian athlete study, which I profile in this book, which I think is, humans want to know about humans. And what's really exciting is you take Italian cyclists and you put them on a training table where everybody has to eat the exact same food, and you do a 3-month study. And all you do is change time of eating. So one group, they eat breakfast at 8 o'clock in the morning. They eat lunch at 4 o'clock in the afternoon, and they have dinner at 8 o'clock at night. Oops, sorry, lunch at 1 o'clock in the afternoon. Dinner
8-1-8.
Okay. 8-1-8. 12-hour eating window. Sounds normal. The other group eats breakfast at 1 o'clock in the afternoon, has lunch 4 o'clock in the afternoon, has to finish dinner at 8 o'clock. 7-hour eating window, followed for 3 months. The punchline is only the athletes in a 7-hour eating window lost weight. They actually lost a lot of weight. The 12-hour guys didn't change their weight. They had identical athletic performance. And here's the best part. The athletes on the 12-hour eating window had a normal insulin-like growth factor 1, IGF-1. The athletes on the 7-hour window plummeted their insulin-like growth factor 1. And if you follow me in other research, IGF-1 is probably our only decent measurement of mTOR activation. And people, super old people in my practice and other practices, have really low IGF-1s. And people with really high IGF-1s, number one, don't live very long. And they
bodybuilders.
Bodybuilders, thanks for that. And they get a lot of cancer, folks.
Yeah.
And we see that in my practice all the time. In fact, it's amazing the number of people with cancer who have elevated insulin levels and elevated insulin-like growth factors. These are growth hormones.
Yeah.
And there's nothing in us we want to grow once we're grown.
Yeah.
Nothing. So, I mean, that's so exciting that here's a human study that actually, proves DeCapo's research that, son of a gun, it's restricting the time of eating. So now let's get back to ketones. So what's happening? So a normal person, and these athletes are normal people, they've got metabolic flexibility. They would start making ketones 8 hours after they stopped eating. And they'd ramp up their ketone production at about 12 hours. But the athletes who are waiting till 1 o'clock in the afternoon, they've got another 5 hours of ketone production compared to the athletes that broke their fast at 8 o'clock in the morning.
So 5 more hours of mitochondrial uncoupling.
Bingo, which now explains why those guys got weight loss, and it now explains why their insulin-like growth factors actually improved.
Interesting.
Yeah. And so it all, when you start looking at this, go, son of a gun, that's how this works. I always want to find out the mechanism. For instance, when we started this years ago, we all knew that hormesis was really good for you. That which doesn't kill me makes me stronger. We had no idea why that was. We knew it existed. I suspect Hippocrates had no idea why all disease begins in the gut. Maybe he knew. We now know why he was right, but it's the same thing with hormesis. It turns out, and the book talks about this, all these things that are hormetic foods or hormetic practices all come together in just one thing. They all uncouple mitochondria. And that's actually what's so cool and exciting.
So cool. Yeah, so fascinating. And I talk a lot about hormesis, but now I'm viewing it from an entirely different lens, thanks to you. So that is so just the awareness for those listening and watching right now. Like, this might be the reason why you can't lose weight on keto. This might be the reason why you don't feel great on keto and why you're struggling. It's all about the mitochondrial uncoupling. So let's talk about, I know your book has several ways to do this, but I want to talk about a few of them, right? So I have a few of my notes here. My favorite is the MCTs, right? And I loved, and I didn't realize this, I learned this from your book, but it's funny because I've been telling all my students to add more sheep and goat dairy and get rid of the cow dairy. And I found out through your book that 30% of sheep and goat dairy is MCT. So explain that, how that helps.
Yeah, so it turns out, so MCTs are this really cool fat that aren't absorbed in the way normal fats are. They go directly through the wall of our intestine to our liver, where they are automatically converted into ketones. So, number one, you could have insulin resistance. You could have metabolic inflexibility. You could take 4 weeks to generate ketones by following a ketogenic diet. Or you could take MCTs and generate ketones. And it's been shown in humans, and I document the studies, that a tablespoon of MCT oil will have you within a half an hour generating adequate amounts of ketones to begin uncoupling mitochondria. So what better way than, if MCTs are easy to take, you can mix it in salad dressing, folks. Some women, really, you got to go slow. Quite frankly, a lot of my female patients, liquid MCT, stomach.
Yeah,
and
I see that
diarrhea.
too.
Yeah. Interestingly enough, in my practice, I see that the powdered MCTs work better for women, and there's a number of MCT powders out there. We put them in the women's coffee, and that seems to work well. But you can get a lot of MCTs by having goat or sheep yogurt or goat and sheep cheese. Now, here's one. It didn't make it into the book, and I wish I fought for it.
Let's share it now.
Well, we all know about blue zones, thanks to Dan Butner. And quite frankly, I'm the only nutritionist who spent most of my career living in a blue zone, Loma Linda, California.
That's
so
right.
I ought to know what I'm talking about. But so two of the blue zones are quite interesting: Sardinia and the Nagoyan Peninsula of Costa Rica. And Dan makes a big point that they eat a lot of bread and grains. The Nagoyan Peninsula eats a lot of corn and beans, and he makes a case that it's the beans and corn. Well, not so fast. It turns out Sardinia has two regions, the mountainous region and down by the coast, and kind of nothing in between. It's only the folks who live in the mountainous region that have extended longevity. So what do those guys do up there? Turns out they're goat and sheep herders. The folks down by the Mediterranean Sea are not goat and sheep herders, and they don't eat goat and sheep cheese. They eat fish. So when there's papers published that the longevity benefit is from the MCTs from the goat and sheep cheese, uncoupling their mitochondria, and they don't get it in the sea. Let's go to the Nagoyan Peninsula. All of Costa Ricans eat a lot of beans and corn. That's their diet. What's so unique about the Nagoyan Peninsula? Want to guess? They're goat and sheep herders. And there's a beautiful paper showing that the benefit of the goat and sheep cheeses and yogurts offset the bad part of the corn and beans. So here we have two blue zones that actually we can attribute their longevity to the goat and sheep cheese. Other fun fact, when I moved to Loma Linda, I was shocked that the Adventist diet is 50% fat, and most of the fat comes from cheeses. Fun fact, who knew? So, but at least two of them are goat and sheep cheese they're actually causing the benefit.
That's so interesting. Oh man, I mean, we have just like 7 minutes to go. I could talk to you for hours. In your book, you also talk about other MCTs, or I should say, other ways.
Uncoupling.
Uncoupling, yeah, which is interesting. The book title is great, and it is about keto, but it could essentially be called, uncoupling and learning all about the mitochondria. You could have like changed the title and talked about that.
True story. I really wanted this title to be. The title was going to be "The Key to Life Comes Down to Just One Thing, and It's Not What You Think," and it's uncoupling.
Yeah,
and you're right. This is a longevity book hidden in a keto book. And I think that's why you and me probably are so excited about the benefits of ketones and a ketogenic diet. But I think this book takes it to the next level, because what I want for people, and what I've based my career is, I want you to have a diet you can live with, literally and figuratively. And I think you and I know that for so many people, particularly, I take care of a lot of vegetarians and vegans, and a ketogenic diet is basically a non-starter for all of them. But you can get all the benefits that ketones bring you with lots of other ways to accomplish the same thing. For instance, I'm uncoupling my mitochondria right now. I have a big glass of tea, and tea is actually a great mitochondrial uncoupler. Coffee is a great mitochondrial uncoupler. Extra dark chocolate, great mitochondrial uncoupling. In fact, so many of the things that we think of as healthy, when you actually look at the literature, their mechanism of action is uncoupling mitochondria.
Yeah, and you have an entire list of your book of other. I'm not gonna give it away, but
I know there's plenty.
Before we wrap up the conversation, I want to touch upon melatonin real quick, and then I want to talk about why we see insulin resistance with long-term ketosis. So melatonin is another way. You said it's one of the two antioxidants that have the ability to actually penetrate the mitochondrial membrane. Are you putting glutathione in the same category as superoxide dismutase?
Yeah, it's in the same category.
Got it. Okay. So Melatonin, you also have a list of melatonin foods that you could eat. And what about supplementation with melatonin? What are your thoughts on that?
That's a great question. First of all, pistachios actually have the highest melatonin content of any food. There's actually some interesting research that I cite that the Mediterranean diet and the French paradox actually get their benefit by the melatonin content of olive oil and red wine, and also actually mushrooms are full of melatonin. And I
And
argue,
vitamin D, yeah.
and I argue in the book that we've associated melatonin with a sleep hormone, but in fact, melatonin comes out at night because it is the major mitochondrial repair hormone, antioxidant. And so it's there at night, not to put you to sleep, but to actually repair mitochondria. I'll give you a personal example that I talk about in the book. Well, a family example. We have a very old, large female Labradoodle whose name is Pearl. And a year and a half ago, Pearl couldn't pee. She had to strain to pee, and she doesn't have a prostate, folks. I mean, she literally could not urinate. And we took her to the vet, and the vet does an ultrasound. And she said, "Oh, I got horrible news. She's got inoperable stage 4 bladder cancer. It's blocking her ability to pee. We'll get you in touch with a veterinary oncologist, but the other option is we just put her to sleep." And I said, "Oh, geez, I know all about treating cancer. Thank you very much for this information." So I put her on my uncoupling program with supplements, which includes this dog takes 48 milligrams of melatonin a day.
Wow.
48 milligrams. She doesn't go to sleep, folks. Turns out that Pearl, within a couple weeks, started peeing. By the time we met the oncologist 2 months later, she was peeing fine. The oncologist said, "Oh my gosh, that's a placebo effect." I said, "The dogs do not suffer a placebo effect."
No, they don't.
And she said, "I want to start IV chemotherapy today." I said, "No, thank you. She's peeing fine." That was a year and a half ago.
Wow.
Pearl walks 2.5 miles every day, plays with the other dogs. She pees like a racehorse. So, quite frankly, uncoupling, I've been uncoupling her mitochondria. And I make an argument in the book that melatonin may be one of the secrets of cancer therapy. And I have a lot of my cancer patients on up to 100 milligrams a day of melatonin in divided doses.
That is interesting. So my colleague, Dr. John Lawrence, wrote a book called The Miracle Molecule Melatonin, and he's presented me so much research. He makes actually a product, a suppository called Sandman with 200 milligrams of melatonin, and one called Super Sandman with 300 milligrams. And I've been taking that. And I've been doing 50 milligrams oral sometimes, but oral is not as highly as absorbed as a suppository. Now, my question to you regarding that is, according to his research, and I haven't found anything to disprove it, is there, if you're taking too much exogenous melatonin, will it shut down the endogenous production? I haven't seen any kind of negative feedback loop with that.
Yeah, that's interesting. And people argue with this. You're right. I have not found any evidence that that's true. It's conjecture. Certainly, if you take exogenous testosterone, your testicles will shrink to BBs, folks. That's true. But I've not seen that that's true in the case of melatonin. And again, I think we've gotten melatonin all wrong. And I make the argument association does not mean causation. And I think melatonin coming out right before the sleep cycle may have nothing to do with sleep. It has to do with the sleeping is when you're repairing mitochondria, when you're cleaning up the Mito club. And when you view melatonin in that way, yeah, I think this may be an untapped hormone, very much like vitamin D, that we should. Vitamin D is a hormone, folks. It's not a vitamin.
That's right. Yeah.
That we should understand, what these things are actually doing. So
Yeah.
I've come around to view melatonin as just a remarkable mitochondrial cleanup agent.
Do you have 3 more minutes, or do you have to run?
Yeah, and until the door, pounds and they say next patient.
Isn't melatonin, majority of it also produced in the gut?
Yes, that's true.
Yeah.
The pineal gland is just one source. And again, I think when you look at the Mediterranean diet in particular, there are multiple sources of melatonin in that diet. And I think, we just have to come at this a whole different way and say, gee, maybe the benefit of the Mediterranean diet, besides all the great polyphenols,
Yeah.
is that a lot of these foods and beverages are melatonin containing foods and beverages.
Last thing before we wrap this up, we both align with going in and out of ketosis. This is my book here. It's called
Yep.
Keto Flex. I think it's important to have that and not stay in ketosis long term. There's a lot of reasons why long-term keto is not good: thyroid health, buildup of 4-HNE, sex hormone binding globulin. But you explained why we see insulin resistance. If you could just explain quickly why we see insulin resistance, and it's a different type of insulin resistance with long-term ketosis.
Yeah. Again, if ketones are actually doing their job by uncoupling mitochondria, by signaling mitochondria that times are rough and to protect yourself at all costs, there's some really cool research that I show in the book that mitochondria will shift protein production to stop making muscle protein and start making more mitochondrial proteins to make more of themselves. Save your cells. Who cares about those muscle cells? They just eat food, the hungry little devils. And as part of that, we know that long-term ketosis, I think because of this effect, produces insulin resistance because you want to cut off muscles from getting calories because they're expendable. For instance, in my first book, you could take trained athletes and put them at bed rest for 48 hours, and they will become insulin resistant in their muscles. Why? Because if you're not moving for 48 hours, there's only one reason you're not moving, and that's you're injured and you probably can't get food. So you got to cut off these hungry muscles from getting food. And the same way with mitochondria and long-term ketosis. I have a very good friend who stayed in ketosis for a year, measured himself every day. And the guy got profound muscle wasting, sarcopenia. And you go, what'd you expect? And he said, well, I didn't expect this. And good for him. He's like me, we'll experiment on ourselves, sometimes to our disadvantage. But yeah, so, and you and I agree, we're designed to have a circadian rhythm of ketones and no ketones. And one of the reasons we've survived, multiple millions of years is we can go an extremely long time living on free fatty acids and producing some glucose from cleaving free fatty acids, triglycerides, getting glycerol, and using some protein stores. But we're not designed to do that 24/7, 365 days a year. It makes no sense. Veach was wrong. Our natural condition is not to starve.
I get a lot of pushback from those in the keto. I'm really in the keto space, and a lot of people don't like the message of keto flexing. So I love your explanation there. Get Dr. Gundry's book. It's available everywhere books are sold. Amazon. Your website's Gundry MD. Anywhere else that you want my keto campers to go check you out?
So, come to the Dr. Gundry podcast, wherever you get your podcasts. I've got 2 YouTube channels. Come to GundryMD.com. If your listeners go to Gundry MD, which is my supplement and food company, if you put in code Gundry30 at checkout, I'll give you 30% off the entire store for your order, just for being a great listener. And thanks for having me.
That's awesome. Thank you, Doc. I appreciate you. What an amazing conversation. We'll do this again sometime in the future, and I appreciate your trailblazing work. Thank you so much for today.
Thanks a lot, Ben. Great to talk to you, and keep up your good work, please.